Hey guys, we are into Unit 7, solving our trig equations. This first little bit of lesson is going to review factoring that you've been doing forever, so hopefully you'll be okay with it. And then we're going to take that skill and that understanding and move it on to factoring trig expressions. So these first examples are actually not written in your notes in your packet. So if you have your packet or you just want to jot them down on a sheet of paper, kind of follow along. Just again, quick review of factoring. So no matter what you are factoring, doesn't matter at all. You always, always, always check for the greatest common factor first. It can be a number, it can be a variable, or it can be a combo of the two. All right, so our first example, 3x squared plus 6x plus 9. Hopefully you recognize everything is divisible by 3, which would leave us 3 multiplied by the quantity of x squared plus 2x plus 3. You would want to check to see if this trinomial does factor. And when you use that little visual method I know you guys like to use, is there anything that multiplies to 3 but has a sum of 2? The only factors of 3 that would multiply to positive 3 are 1 and 3, both positive or negative, and that's not going to work. Okay, so there is nothing else you can do for this example. It only had that GCF of 3. I'm sure you recognized it, but I'm just going to chat through. Example 2, 2x to the 7th plus 4x cubed plus 10x. You'll notice that each of the coefficients of your terms are divisible by 2, and each term has at least x to the first power. So your GCF is 2x. Remember, when you're dividing through or factoring out a variable, you're basically just subtracting the exponents. Divide your coefficients and subtract your exponents. So 2x to the 7th divided by x would give me 2x would give me x to the 6th. 4x cubed divided by 2x would give me a positive 2x squared, and 10x divided by 2x would give me a positive 5. Again, if you tried to factor this one, there would not be anything that would multiply to 5 and add to positive 2, so it doesn't factor any further, just had the GCF. Our next quick review is a difference of two squares. So remember, the D is for difference. Is there a minus sign? Of 2 means only 2 terms. And then the S stands for, can you take the square root of each of those terms? Are they perfect squares? Okay, so check them. X squared minus 25. Do I have a minus sign? Yes. Do I only have 2 terms? Yes. And can I take the square root of x squared? Yep. Can I take the square root of 25? Yes. So we're going to have an x plus 5 and an x minus 5 as my 2 factors. There you go. All done. I know most of you guys probably recognize that and just flew past it. Follow the same pattern for the next one. It's okay if you have more than one variable. There's nothing wrong with that. Double check. Do you have a minus sign? Yes. Can you take this, or do you only 2 terms? For sure. And can you take the square root of 9x squared? Yep, that would give you a 3x. Can you take the square root of 16y squared? Yes, that would give you a 4y. So my factors need to be exact opposites, 3x plus 4y and a 3x minus 4y. There you go. Remember, in the order that you write your factors doesn't truly matter as long as they're actually correct. So have the correct terms with the correct signs, and we're good to go. We're now moving on to trinomials. I know a lot of you guys like to use this little cross or diamond method that we do. The first examples only have a leading coefficient of 1, so these you typically should be able to kind of do in your head, unless you get some super big huge numbers, and you might want to take a moment and just double check. So GCF for x squared minus 10x plus 24, other than 1, there's nothing there. So we're going to look at our visual method of multiplying or finding our factors. What multiplies the first and the last? So A times C, 1 times 24. What multiplies to 24 but has a sum of B, your bottom term, your B, negative 10? Okay, our factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Since we're multiplying to a positive value, they both have to be positive or both have to be negative. And hopefully you recognize negative 4 and negative 6 have a sum of negative 10 and a product of positive 24. If you want to see the full gamut of this guy, you would put the little first term underneath and look to see if they simplify, and they don't. So your factors are x minus 4 and x minus 6. Example 6, very similar, x squared plus 2x minus 15. Again, a GCF other than 1 is not there, so we're good to go. What multiplies to negative 15 and has a sum of positive 2? So I need one positive and one negative value in order to multiply to a negative. So I can do 1 and 15 or 3 and 5. All right, it's got to be 3 and 5. So determine if I have a negative 3 and a positive 5. Negative 3 plus 5 is 2, or 5 minus 3 is 2, and those multiply also to negative 15. Cool. So those are your factors, an x minus 3 and an x plus 5. You'll notice in that example I didn't write the little x underneath because that leading coefficient is 1. So those should always be the values that you use for your factors when you get what multiplies to the numerator, to the top, and adds to the bottom. Our next set of trinomials, these all have a leading coefficient other than 1, so we're still going to use that same visual method. And then again, always just double check. In this case, we will need to use those lines in the middle so that we can simplify with that first term. 3x squared plus 10x minus 8 does not have a common factor between the three terms, so we're going to multiply first times last. 3 multiplied by negative 8 multiplies to negative 24. So what multiplies negative 24 but has a sum of that middle term, positive 10? And we just looked at those factors. They were 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I could use 4 and 6, but they would both have to be positive to give me the positive 10, and I need to multiply to a negative. So one's got to be positive, the other's got to be negative. So let's go back up and choose our factors of 2 and 12. So 2 and 12. 12 minus 2 gives me 10. So I want the 2 to be negative and the 12 to be positive. And then I'm going to take that first term, drop the exponent, but tuck it either above or below those factors you just wrote down. Look to see if they simplify. 3x and negative 2 do not reduce, so those are your factors, 3x minus 2. And 3x and positive 12 both do reduce by 3, which would leave me with x and a positive 4, so our other factor is x plus 4. 3x squared plus 10x minus 8 has factors of 3x minus 2 and x plus 4. We'll do the same thing for number 8. Again, check for that GCF. 6x squared minus 15x minus 21, all divisible by 3, guys. Take out a GCF first. It'll make life easier. So 3 multiplied by the quantity of 2x squared minus 5x minus 7. And now we can do our little visual diamond method with the trinomial 2x squared minus 5x minus 7. Again, multiply first and last. What multiplies to negative 14 and has a sum of the middle term, negative 5. Let's see, 14 gives me 1 and 14 and 2 and 7. It's got to be 2 and 7 again. So I'll put a 2 and a 7. And let's see, I need negative 7 plus 2 to give me a negative 5, or 2 minus 7 gives me the negative 5. Put that first term with these factors that you have, so 2x on both of those guys, and see if they reduce. 2 and 2x are both divisible by 2, so that would give me a positive 1 over x, and that would be one of the factors. 2x and negative 7 do not reduce, so that would be another factor. The thing you have to remember is keep that GCF, do not lose it. So it's 3 multiplied by x plus 1, and then multiplied by 2x minus 7. There you go. Our last two examples are factoring by grouping. When you have 4 different terms, you're going to sometimes have to rearrange them, but hopefully not, so that you can group the first 2 terms together and find a GCF of them, as well as the back 2 terms and find a GCF for them as well. So our first example is 5x cubed plus x squared plus 10x plus 2. Everything's positive, makes it so much cleaner and nicer. Again, group those first 2 terms, 5x cubed and x squared. they have an x squared as their GCF, and when I factor it out, I'm left with a 5x plus 1. In the back two terms, I want to make sure I group that sign with it. So I'll have a positive 10x and a positive 2. They're both divisible by 2. And when I divide them by 2, I'm left with a 5x and a positive 1. My whole goal is to get an exact identical twin factor between those two sets, which I did get, the 5x plus 1. And then I can take the other terms, the x squared and the positive 2, and write them together to become our other factor. So our two factors are x squared plus 2 and 5x plus 1. We should always look at anything that is squared and double check to see, is it a difference of two squares? Do you have a minus sign between the x squared and the 2? Nope, so it's definitely not a difference of two squares. You could factor it, but it would deal with imaginaries, and we're just not going to deal with that today. So those are our factors for example 9. In example 10, we have 2x cubed minus 3x squared minus 2x plus 3. Follow the same pattern, group your first two terms. Again, those only have a GCF of x squared, leaving me with a 2x minus 3. And in our back two terms, we have a negative 2x and a positive 3. Anytime that third term is negative, make sure that you factor out a negative. So I need to factor out the only thing common between the negative 2x and the 3 is 1. So I'm going to factor out a negative 1. And when I divide through or factor out that negative 1, that would leave me with a positive 2x and a negative 3. And that's exactly what I wanted. I wanted that to be identical to the other factor. So one of my factors is 2x minus 3. And the other factors in the front, the x squared minus 1, became our second factor. So we have x squared minus 1 multiplied by 2x minus 3. Okay, let's double check. Is the x squared minus 1 a difference of two squares? Do I have a minus sign? Yes. Only two terms? Yes. Can I take the square root of x squared? It's x. Can I take the square root of 1? It's 1. So this one does factor farther. X plus 1, x minus 1, and then you'll keep your 2x minus 3. So you can take this example out into 3 linear factors. That is it for our review of factoring. I am going to continue on and jump into the next part. So our video is going to be a little bit long, but just stick with me. That was a good review for us. So now we're actually going to look at factoring our trig expressions. I'm going to equate it exactly to what we just did with regular factoring, and we will do the substitution method to kind of help us as needed. So our first example is cosine squared of x minus cosine of x. Okay, so we're going to go back to the things that we looked at. We first always look for a greatest common factor. After that, we'll check for a difference of two squares. And lastly, we'll check for trinomials or factoring by grouping. Okay, so what I think most of us kind of recognize that this one does have a GCF. There's a cosine squared minus a cosine, so they both have cosine as a value or as a variable, a term, whatever you want to call it. So I can factor out cosine of x. In essence, you're kind of dividing each term by cosine of x. So cosine squared divided by cosine is cosine of x, and negative cosine of x divided by positive cosine of x is negative 1. So this does factor to be cosine of x multiplied by cosine of x minus 1. That's as small as that guy can get. Okay. If you would like to equate it to a regular problem, which I'm going to do for the remainder, so I'm just kind of showing you how this works on this one, it's pretty easy. Let any variable you like, x, represent cosine. So anywhere I see a cosine, I'm going to replace it with an x, and then I'll get back to stuff that I've been doing since Algebra 1, and the factoring will just kind of process a little bit easier for us. So cosine squared x would be x squared minus cosine of x would just be an x. Okay, equivalent. And then here I would look to see, okay, they both have a GCF of x, and when I factor that out, I get an x minus 1. So you can take this step And then you would have to go back and replace your x's with cosines so that you get the factor that we did have, cosine of x multiplied by cosine of x minus 1. Okay, with GCF problems, you guys usually pick those up fast enough, so you don't have to do that step. But for our trinomials, like in this example, 2 cosine squared of x minus 3 cosine of x plus 1, it will help us if we let something replace the cosine so we can process it through like a regular factoring example. So we're going to check for, I'm first going to replace all the x's or all the cosines with x, and then we'll check for a GCF. So cosine equals x. So 2 cosine squared of x would be 2x squared. Minus 3 cosine of x would be minus 3x, and plus 1 stays as is. Okay, now check for a GCF. Anything other than 1 or negative 1? Nope, not at all. So we're going to go back to, is it a difference of two squares? Definitely not, because it's a trinomial. So we are at the trinomial section, and we are going to draw our little diamondy thing that we do to help us. Remember, first times last, what multiplies to 2 and has a sum of the middle term, negative 3. The only factors of 2 are 2 and 1. To multiply them to be positive, they can both be positive or both negative. I need them in this case to both be negative so that their sum will be negative 3. And now I'm going to take that first term, 2x, put it over top, and see if it reduces to get my factors. 2x over negative 2 reduces to give me an x over negative 1, so that's a factor. 2x over negative 1 does not reduce. So 2x squared minus 3x plus 1 factors to be x minus 1 multiplied by 2x minus 1. Now that answer is fine, but it is not in terms of cosine. So we're now going to rewrite what we just factored in terms of cosine. X minus 1 becomes cosine of x minus 1, and 2x minus 1 becomes 2 cosine of x minus 1. There you go. That's it, gang. That's all you got to do. Our next example, sine cubed of x minus 5 sine squared of x plus 6 sine of x. Again, we are going to let x represent sine of x, so we can rewrite this using our substitution method. So we're going to say x cubed minus 5x squared plus 6x. I'm always going to check for a GCF, which I definitely have. I can factor out an x, and that would leave me with an x squared minus 5x plus 6. And then we're going to check for a difference of two squares. That's a big fat no. This guy again is a trinomial. So we're going to look to see what multiplies to positive 6 but has a sum of the middle term, negative 5. So again, I'm looking for two negatives. Negative 3 and negative 2 have a sum of negative 5 and add to give me, or excuse me, multiply to give me positive 6. And then I'll take that x term and put it over top. So I can further factor this to be x, the GCF, multiplied by x minus 3 and x minus 2. Okay, take it one last step, put it back in terms of sine. So anytime I see an x, I'm going to replace it back with a sine of x. Sine of x multiplied by sine of x minus 3, and then multiplied by sine of x minus 2. Okay, you guys, just a quick little intro of our next lesson. The reason we're doing this is because in our next lesson, we're actually going to start solving for values of each of our trig functions that land on the unit circle. So if I were to actually solve this, let's pretend that this all equaled 0 at the beginning. Okay, so now that I have it factored, I've got to break it down. I can't just look at sine cubed of x and go, yep, it's that at 0. No, you can't just do that. You got to look at every single term individually. So factor first, and then you would set each factor equal to 0 and solve for them with their values around the unit circle. We will learn how to do some that are not on the unit circle, but we're going to start with these first. So sine of x equals 0. This means where does the y value equal 0 on the unit circle? Question mark. Technically what we would do is we would do x equals sine inverse of 0, which means find the inverse, find the angle measure or the radian. So our x represents our angle and our y values are 0 at 0, at pi, and at 2 pi. Those would be our three solutions for that particular factor. I know I'm jumping ahead. We're supposed to be factoring. I just want to show you this real quick. Our next factor, sine of x minus 3 equals 0, we would set sine of x equal to 3. Is there anywhere on the unit circle where sine equals 3? Look around. I promise you there is not. So there's no solution for that particular factor. And then we would do that for our last factor, sine of x minus 2 equaling 0. Is there anywhere on the unit circle where sine of x equals positive 2? It does not. It equals positive values, but the largest it gets is positive 1. So again, that third factor would also give us another no solution. We would only use 0 pi and 2 pi, or 0, 180 degrees and 360 degrees as our solutions if this was an equation. I won't do it again on the others. I just wanted to give you a little tidbit for the next lesson. Back to factoring. Factor tangent to the fourth of x minus tangent squared of x. Okay, so again, let's get back to what we're doing. Let x equal tangent of x. Then we'll go through the process of GCF, difference of two squares, and so forth. So tangent to the fourth of x would be x to the fourth, minus tangent squared of x would be minus x squared. Okay, back into things I recognize. Is there a GCF? For sure, x squared. So I'll have x squared multiplied by x squared minus 1. That's good. Can you go any farther? The next thing that we check is a difference of two squares. The GCF is not, it's just a GCF. So x squared minus 1 is a difference of two squares. Yes, this is a dots. So we are going to keep our GCF and factor x squared minus 1 to be x plus 1 multiplied by x minus 1. There's nothing else that we can do to simplify this, so now we put it back in terms of tangent. So x squared becomes tangent squared of x, x plus 1 becomes tangent of x plus 1, and x minus 1 becomes the factor tangent of x minus 1. Those are your three factors for this example. Last example for factoring. You guys have plenty that you can practice on worksheets A for regular factoring and worksheet B for factoring your trig expressions. Sine to the 8th of x minus sine to the 4th of x. Looks kind of similar to what we just did. And we're going to start off again with our substitution method, letting x represent sine of x. So sine to the 8th of x would be x to the 8th, minus sine to the 4th of x would be x to the 4th. Is there a GCF? Definitely. X to the 4th can be factored out from each of those terms to give us x to the 4th minus 1 in parentheses. All right, is that x to the 4th a difference of two squares? Again, we don't have to worry about that GCF because it's just going to hang out there. So let's think about it. I know the square root of 1 is 1. There's a minus sign, there's only 2, and I can take the square root of 1. Can you take the square root of x to the 4th? Like, can you break that down to be the same thing multiplied by itself? You sure can. X squared times x squared. So the square root of x to the 4th is x squared. So this guy is a difference of two squares. We're going to write it x to the 4th, and then I want an x squared plus 1 and an x squared minus 1. Okay, cool. Got that done. Double check. GCF's good. Our next one, x squared plus 1. That's not a difference of two squares. That will give us imaginary solutions. Don't factor that one. Just leave it as it is. X squared minus 1, guess what? Another difference of two squares. We got a double whammy on that dude. So we can factor that last factor one more time. X to the 4th, x squared plus 1, and then we'll have x plus 1, x minus 1. That is factored completely. Now put it all back in terms of sign. So we'll have sine to the fourth of x multiplied by sine squared of x plus 1 multiplied by sine of x plus 1 and then multiplied by sine of x minus 1. There you go. That's got 4 separate factors. Again, you guys should be looking at regular factoring problems on worksheet A, and then practicing some more trig factoring on worksheet B. Just a note, if you see any problems on either of these that really kind of aren't in our format, like we like 2x squared plus 3x plus 1, if you saw something 2x squared plus 1 plus 3x, just rearrange that constant term, just move that dude to the back so that it looks normal, okay? And same thing if you had any cosines or sine or tangent or any of that kind of thing. So if I had, let's say 2 cosine of x plus cosine squared of x minus 3, rearrange it, write it as, oopsie, excuse me, cosine squared of x plus 2 cosine of x minus 3, and then try to factor from that particular set. So I hope this helped you guys get a start of reviewing your factoring and working with factoring trig expressions. Have a great day. Make sure you practice.